Hello everyone, today we are going to talk about chain ladder method. The chain ladder method, also known as loss development method or loss triangle method, is another popular loss reserving method. This method observes patterns in historical loss development and assumes that future losses will continue to develop in a similar manner. So here you can see there is a table on the left side where it has accident year and development year. So, and the accident year means the year when the accident happens, and development year it means the year after accident happened. Each year, how much claims you will need to pay. So this method is called loss triangle method because of how the data is arranged, as you can see in the table. The historical data forms a triangle at the top. This triangle is also called a run-off triangle. For this method, the goal is to project values for lower triangle. That is the empty cells. This value will represent the reserve. So to start, let's denote the incremental losses as LIK, the small l, where I represent the accident year and K represent the development year. For example, L 2013-2 will be the 23rd row in 2013 and column in column where it's 2, so it's the third column, where you can see the loss is 430. This loss is just loss for that year, but on the other hand, we can accumulate all the losses through a year. That's how we develop the triangle on the right side. This loss here is the cumulative loss. So here you can see, for example, bigger L 2011-3 means the accident year 2011, and the amount in this cell is 1660, which is the accumulative loss from year 0, development year 0 to year 3. So it's 590 plus 490 plus 380 plus 200 altogether. So this is the difference between incremental losses and cumulative loss payment. Now, the chain ladder method assumes that historical loss development are indicative of the future. We will quantify the loss development between DY5, development year 5, and development year 6 by calculating the ratio of the cumulative losses rounded at the development year 6 to those recorded in development year 5 for accident year 2011. So for example, in this case, we use L 2011 6 divided by L 2011 5, which is 1A30 over 1A00, which is 1.017. Now this ratio can be used to derive the number for 2012 6, because we assume the ratio remains the same. So here this number would have the same ratio if we divide it by development year 5. Therefore, we can derive that the year 6 value for 2012 would be 1.37K times 1.017, which is just the ratio we got from previous step. And then we got 1393 here. So here is 1393. Now, if we get to next row 2013, there are two empty space. development year 5 and development year 6. In this case, we could have two development factors, lost development factors, because you can derive one from 2011 and derive one from 2012. So what's going to happen here is that we utilize both factors. Since they are different, we average them to be 1.028. With that, we can calculate the value for this by using the new factors 1.028. And again, we also use the original factor we get from first step 1.107 to populate this. So you can see for the next step, you will have three ways to determine a factor. Then you just need to calculate the factors for the three rows, but average them. That's where you get the next step. And similarly, you can further fill in all the empty space in this square or rectangle. But the lower triangle will be the one that you want to fill in. The way to fill in is just utilize the development factor. The assumption is that the development factor would remain the same. But when there are two different development factors, you average them, or even in the last case, you probably have 5 development factors. You have to average all of them together, 6 actually, development factors from 2011 to 2016. You average them together, that would be the development factor you would use for 2017. The reason is the more data you have, the more accurate your estimate will be. So this is the gist of train ladder method. Again, this page just generalizes the train ladder method for you. First, calculate the loss development factors, which are also known as age-to-age factor or link ratios. Then the next step is to select the age-to-age factors. There are many ways to select factors, but we will cover 3 common methods. Averaging. Averaging method is what we just did. We average all the factors that we have. Alternatively, we could do n-year average, find the arithmetic average of the n most recent loss development factors under 3-year average model. We get this. Then the third method is mean or volume weighted averaging. Find the sum of the cumulative losses in a given development year divided by the sum of the corresponding cumulative loss from the previous development year. Note that the numerator and the denominator must have the same number of entries, for example, this. The model gives us select age to be this. So anyway, these are 3 different ways to calculate to determine the development factor. One is just a simple averaging. The other one is m-year average. Find the average of the most recent loss development factor. Uses 3-year average. We get so F1 you still just be the same as F1. F2 will still be the same as F2. But F3 here is calculated by averaging all 3 of these F1, F2, F3 together. Then again, F4 will be the average of F3, F2, F3, F4. So in this place, 1.104, how it's developed is by adding 1.873 plus 1.311 plus 1.112 divided by 3. Similarly, 1.10451 will be equal 1.311 plus 1.112 actually plus 1.051 divided by 3. So it's always a 3-year average. The third method is volume weighted average, where you have to utilize the cumulative loss of several years, accident years. You add them together and divide it by the one that in the front. It's also several years together to get the weighted average. So these are 3 different ways to calculate the factors. Okay, this page is just a further demonstration how you can utilize these factors to estimate the loss for each development year. Basically, you are just applying the factors, but when you have 2 years, you can have 2 ways. That's what it's supposed to be. So, for example, in this for this 2012 the 6th development, you only have 1 factor there, so you just multiply the factor 1.017 by 1370 to get it. But if you are calculating this number 2013 with development 6th year, you could calculate this 5th year first, then calculate 6th year, or you can start from 4th year and just apply the cumulative sum of these 2 factors. It would have the same effect to get to the final number. But this is how you can utilize these factors. Once you have estimated ultimate losses and the losses paid to date for all accident year, we can calculate the loss reserve for each accident year. Note that we don't need to hold the reserve for accidental year 2011 because those claims have fully matured. So starting from 2012, we just need to estimate the ultimate loss, which basically is filling every empty space in a triangle. Then loss paid to date will be the sum of each rows that are already shown in the triangle. Then the loss reserve will be the difference between the ultimate loss and the loss paid to date. In this example, you just need to calculate loss reserve for each of the years from 2012 to 2017, and since we know the loss paid to date number here, then the difference is loss reserve, and we add them together to be 3412. So on the right side is just a summary of this method in general. You have to calculate and select the age-to-age factor, then project the ultimate losses, subtract the loss paid to date to estimate reserve. It's worth noting that we can combine loss development factor from the current age to the ultimate age to create age-to-ultimate factors, which directly develop some current losses to ultimate losses. The age-to-ultimate factor is calculated as the product of all age-to-age factors beyond current age. The estimated ultimate loss can be calculated as the loss paid to date times the age-ultimate factor. That's basically what was shown in previous example already. Now let's look at a real example. For claim of AY for accident year 4, the loss paid to day as of 12/31st, AY7 is 100,000. You are given the following H2 ultimate factors. Determine the chain ladder estimate of the unpaid loss of AY4 claim as of December 31st, AY7. So in this case, the reserve is an estimate of the outstanding payments. We are looking to calculate the reserve for AY4 claims. The AY4 claims are H3 at the end of AY7. Lastly, estimate our ultimate losses are 100,000 times 1.108. This varies because it's the H3. This means the estimated unpaid loss will be 110,800 minus 100,000, which is equal 10,800. Now let's look at this second example. You are given the following cumulative paid losses. Assume no loss development beyond development year 3. Using the chain ladder method and the average factor model, estimate the loss reserve as of December 31st, AY4. So we are given the cumulative losses already, so we can calculate the age to age factor. After that, to select factors using the average factor model, take the average of each columns. So basically, we are just average of each column to get the factor. F1 will be 1.67, which is 1.67 6 plus 1.611 plus 1.722 divided by 3, I believe. The second one is 1.2, which is the average of 1.175 and 1.224. So basically, these three will determine the first one. These two will determine the second one. Then the third one will be determined directly 1.209. With this, we can estimate the ultimate losses. The claims of AY1 are fully developed. There's no need to hold a reserve for these claims. And the second year, ultimate loss will be 710 times 1.209, which is 858. For the third action year is 899. For the fourth year is 993. Then from here, we can calculate the reserve, which is the ultimate loss minus the loss paid today. So it's for AY2 is 148, AY3 is 279, AY4 is 583. You add them all together, you get the reserve to be 1011. Now let's look at the last example. You are given the following cumulative incurred losses experience. Using the chain ladder method, estimate the loss reserve at the end of 2015. Use the volume-weighted average factor model with no development past 24 months. So the selected 6 to 12 months factor is 3872 plus 3869 plus 3876 divided by 2893 plus 2937 plus 3068. It turned out to be 1.295. So the reason is this way is because it's asked for weighted average. When it's a weighted average, you sum them up together, divided by the one in the front to get the factor. Rather than doing it one by one, then average, that's another way to do it, but that's not what it asks here. The selected 12 to 18 months factor, similarly, you can calculate to be 1.098. And the last one is select 18 to 24 months factor will be 1.02. The claims on 1214-1 are fully developed and paid. The claims on 1214-2 are 18 months at a variation. Thus, the ultimate loss are 4255 times 4340. So here you need to understand this because it's estimate every half year. That's why it's 2014-1, 2014-2. The claim of 2015-1 are age 12 months at variation. Thus, the estimated ultimate loss are 3876 times 1.098 times 1.02, which get to 4,340. The claim for the second half year of 2015 age 6 months at variation. The estimated loss can be calculated to be 4765. Finally, subtract the loss paid to date from the ultimate loss to estimate reserve. So loss paid to date is already given in the example, and we already calculated the ultimate loss. Reserve can be calculated to be 3839.